Hello everyone, today we are going to talk about the metric system. So the metric system is basically the units that we use when we want to measure length, volume, and mass. So the unit that we use for length would be meter, for volume it would be liters, and for mass it would be grams. For temperature it would be degrees Celsius. The metric system is used all around the world. In the United States, the metric system is used in the lab, but in the United States, in our everyday lives, we don't really use the metric system. So when we measure our height, for example, we don't use meters, we use feet and inches. When we put gas in our car, we measure the volume in terms of gallons. When we weigh ourselves, we don't weigh ourselves in grams, so we use pounds. And then for the temperature, we use Fahrenheit. But as I said, in the lab, we must use those units right here. What we normally use in our everyday lives, we refer to it as the English system. So we say that the basic units for mass, it's grams, for volume, it's liters, and for length, it's meters. Those are the basic units. Instead of writing the whole entire word gram, we could just abbreviate it by the letter G, and then liters, we can just abbreviate it as L, and meters as M. Now, those basic units, we can either make them larger or smaller, and we do that by adding a prefix in front of that basic unit. We have multiple prefixes all the way from giga to angstrom. So we can say, for example, gigaliter. I can say megameter. You can say milliliter, microgram, nanogram. So you can put those prefixes in front of the basic units. The more we go towards the giga, the more we are going to a larger unit. So the more the unit gets larger. So for example, gigameter is way larger than centimeter. The more you go towards angstrom, the unit is getting smaller and smaller. So nanometer is way smaller compared to millimeter. Now you will notice that between each prefix, there are those jumps or loops, and each loop is basically worth a certain amount of points. So between a giga and a mega, it's a loop worth 1,000 points. Between mega and kilo, it's another 1,000. Between kilo and any of these basic units, it's 1,000. Between any of those basic units and deci, it's 10, and you get the idea. So each loop is worth a certain number of points. So for example, between micro and nano, this loop is worth 1,000. Now those numbers up at the top right here, we always multiply them. We never add them. What does that mean? So for example, if I want to say 1 gram, which is right here, is equal to how many centigrams? 1 gram is equal to how many centigrams? Look at the chart. So here's your gram and here's your centigrams. How many loops do you have between the gram and the centigram? Notice how there are 2 loops. Okay, each one is worth 10 points. So am I going to add those tens right there? So am I going to say 1 gram is equal to 20 centigram? No, do not add, but multiply. So you're going to say 1 gram is equal to 100 centigrams. let's say I want to figure out 1 meter is equal to how many millimeters. Notice how between the meters and the millimeters there are 3 loops. So you're going to multiply, again, 10 by 10 by 10. So that means that 1 meter is equal to 1,000 millimeter. So those numbers up at the top, you always multiply them. One more example, I can say 1 liter is equal to how many microliters? So you have 1,000 right here, and then you have 3 loops, each worth 10. So you're going to multiply all of them. So 1 liter is going to be equal to 1,000,000 microliters. So as I said, always multiply and do not add those numbers up at the top. 1 megagram is equal to 1,000 kilogram. 1 megagram is equal to 1,000,000 gram, because you're multiplying 1,000 by 1,000. You would get those 6 zeros. Now, notice right here where I wrote down that if you're going to move to a smaller unit, you're going to multiply, and if you're going to go towards a larger unit, you should divide. What does that mean? Let's go ahead and take a look at a few examples. But actually, before I go over a few examples, and you might be noticing those symbols right here, those letters, and wondering what they refer to. So that's just abbreviations, okay? So instead of writing the whole entire word giga, you just put capital G, etc. For micro, the symbol that we use for micro is this right here. It's kind of like a U, but it's kind of a bit different. But sometimes instead of that U right here for micro, sometimes they would use the symbol MC. So MC could also mean micro. So you could say microgram, microliter, and so you would say MCL, microliter. Or instead of MC, you would put this symbol right here, and then in front of any of the basic units. So again, those are just abbreviations for those terms. Okay, so let's go ahead and take a look at an example if I want to convert to a smaller unit. So let's say that I want to figure out how much is 1 gigaliter. How many liters would that give me? So I want to go from giga to liter. Notice how giga is way larger compared to my liter. So if I want to convert from giga to liters, I am moving towards a smaller unit. Okay, so the first thing you want to do is figure out how many loops do you have between your giga and your liter. Notice how you have 3 loops and each one is worth 1,000. What are you going to do with these numbers? Well, you are going to multiply them. So 1 gigaliter, multiply all of your, thousands, and you're going to get such a huge number with so many zeros, right? So it's basically like 9 zeros, okay? So an easy way, instead of writing all of those zeros down, is to go ahead and use what's known as the scientific notation. So the scientific notation, we say 10 to the power of how many times really in this case are you moving your decimal towards the right. So right here you're going to count. So let's imagine that there is a decimal after my 1. So I am moving it 1, 2, 3, 4, 5, 6, 7, 8, 9. So moving my decimal towards the right 9 places. So the scientific notation, I could just say 1 gigaliter is equal to 10 to the power of 9 liters. Let's try another example. Let's say that I want to go from decigrams to micrograms. Deci to micro. Again, notice how I'm going towards a smaller unit. So if I want to go from deci to micro, figure out how many loops do you have. So you have 3 loops. 2 of them are worth tens, and then this one is worth 1,000. Again, you're going to multiply all of them. So 1,000 times 100 is going to give you 100,000. Don't forget to write down your units. So 1 decigram is equal to 100,000 micrograms. If I want to write it with scientific notation, instead of writing all of those zeros down, again, imagine that there's a decimal after the 0, and you're just going to move towards the right. So 1, 2, 3, 4, 5. So I'm going to say 1 decigram is equal to 10 to the power of 5 micrograms. Now, notice how whenever you're going to a smaller unit, you're going to be multiplying, and your answer is always going to be higher. Now, if you're going to a larger unit, you're going to divide. So, for example, if I say 1 decimeter is equal to how many meters? So notice how I'm going towards a larger unit. So between the decimeter and the meter, there's 1 loop worth 10. Now this time I'm going to divide because I am going to a larger unit. So I'm going to divide, so I'm going to say 1 divided by 10 because I'm going to a larger unit. So 1 divided by 10 is basically 0.1. You're basically this time moving your decimal towards the left. So imagine there is a decimal by the 1, so you're going to move it to the left, so 0.1. How can I write that using scientific notation? You would say 10 to the negative 1. Why negative? The negative here means that you should be moving your decimal towards the left. Let's try another example. 1 milligram. So here's my milligram. I want to figure out 1 milligram is equal to how many grams? So how many loops do you have? You have 3 loops, each worth a 10. So I'm going to say 1 divided by 1,000. Again, why 1,000? Because I have 3 loops, each worth 10, but I'm not going to, I have to divide by 1,000. Why am I dividing by 1,000? Because I'm going to a larger unit. So 1 divided by 1,000. Again, imagine you have a decimal point by your 1, and you're going to move 3 places. So it's going to be 0.001. Or in scientific notation, it would be 10 to the negative 3. Why to the negative 3? Because I moved 3 spots towards the left. So whenever you're going to a larger unit, you're going to be dividing, and you're going to notice that your answer is going to be smaller compared to what you started off with. Whenever you're going to a smaller unit, you are going to be multiplying, and your answer should be larger compared to what you've started off with. Alrighty, let's go ahead and take a look at a few more examples. And let's say that this time they ask you to show your work and use dimensional analysis. So basically, they're asking for you to show them how did you go from, let's say, meters to centimeters, and they want you to kind of show your steps, and we call it dimensional analysis. So let's go ahead and kind of, take a look at that together. So let's say that I want to go, I want to convert 2 meters to millimeters. Okay, so I want to go from 2 meters, and I want to figure out, how much is that going to give me in millimeters. So what I'm going to do, okay, so I'm going to say 2 meters. I want to go ahead and get rid of my meters. So to get rid of my meters, I'm going to put my meters on the bottom so that they can cancel out. And then I'm going to put my millimeters up at the top. Again, this is how you would show your work in terms of how did you get rid of your meters and how are you going to the units that you want. So whenever you are using this chart, there's a rule that says the larger unit gets a 1 next to it. So if I want to go from meters, which is right here, I want to go to millimeters. Obviously, meters is larger than millimeters, so I'm going to put 1 next to my meters. How many loops do I have between my meter and my millimeter? Well, I have 3 loops. Each is worth 10. So I'm going to multiply them, and that's going to give me 1,000. Okay. What am I going to do? Remember how we said we are going to multiply. So I'm going to multiply my 2 by my 1,000, and so that's going to give me 2,000 millimeters. Okay. Now, again, you don't really have to show all of this. If you just know the chart and you know that between meters and millimeters there are 3 loops, each worth 10, then you can just say right away 2 meters is equal to 2,000 millimeters. Okay, but if they do ask show work, then this is how you could do it. This is one way how you could do it. So let's say I want to, instead of writing 2,000, I want to go ahead and write it using scientific notation. Then what I'm going to do is I'm just going to say 2 times 10 to the power of 3 millimeters. Because again, if there is a decimal like right here, then basically I'm just moving it to the right 3 spots, so that's why I said 2 times 10 to the 3. Let's just, try another one. So let's say I want to, I'm sticking with the number 2, so let's say I want to go from, to millimeters, and I want to figure how much is that in terms of, let's say, nanometers. Okay, so what I'm going to do, okay, so here's my 2 millimeters. Okay, I'm going to put my millimeters on the bottom, my nano on the top. Millimeter is obviously larger than nano, so my millimeter gets the 1. I have 2 loops, and each one is worth 1,000. So I really don't have space, so I'm just gonna use scientific notation right away, because 1,000 times 1,000 is 1,000,000, and 1,000,000 you have basically 6 zeros. So instead of writing all my 6 zeros out, I could just say 10 to the 6. So there you go. It's going to be 2 times 10 to the 6 nanometers, because your millimeters canceled out. And that's going to be your answer. So that's, those are a few examples, and you can see that whenever you're going to a smaller unit, you're going to be multiplying your answers. Let me kind of show you another example, and let's say this time I want to go to a larger unit. So let's say I want to convert, and I'm sticking with the number 2. So let's say I want to convert 2 meters, let's just make it simple, to kilometers. Okay, so this time I'm going definitely to a larger unit because I'm going to kilo. Check out right here the chart. So here's the meters, here's the kilometers. You have 1 loop, and that 1 loop is worth 1,000. So Again, without showing work, you would just say right away that since I'm going to a larger unit, I need to divide. And so by how much are you going to be dividing? By 1,000, because between meters and kilometers, it's 1,000. So you're just going to divide your 2 by 1,000. If you want to show your work, so here is your meters. You're going to put your meters on the bottom so that it can cancel out. You're going to put your kilometers up at the top. Which one is bigger, kilo or meter? Definitely kilo is bigger, so kilo gets the 1. How many loops do you have between kilo and meter? 1 loop worth 1,000, so I'm going to put my 1,000 down here. So what am I going to do? I'm going to do 2 times 1, okay, because they are on the same row right here. So 2 times 1, well, it's just 2. And then you're going to divide by 1,000. So what does that mean? It means that you're going to be moving your decimal 3 points towards the left. So like if here's my 2 and here is my decimal point, I'm basically going to be moving it. So 1, 2, 3. So my answer is going to be 0.002 kilometers. Okay, because again, you've moved your decimal 3 points towards the left. Okay, so how can I write that in terms of scientific notation? You can just say 2 times 10 to the negative 2 times 10 to the negative 3 kilometers. Again, negative 3 because you've moved it 3 spots towards the left. If you've only moved it 2 spots towards the left, so let's say you want to go from centiliter to liter, right? So if you want to go from centiliter right here to liter, you're going to divide by 100, right? So your answer, instead of 2 divided by 1,000, it would just be 2 divided by 100. So it would be 0.02, or 2 times 10 to the negative 2. So since you only moved it 2 decimal points towards the left. And that's how you can show your work, how you've deleted the units that you don't want and how you've ended up with the units that you want. And you will notice that whenever you are moving to a larger unit, notice how we are always dividing. And then whenever you are going to a smaller unit, you are going to be multiplying. Now, by the way, another thing to know about scientific notation is that if you ever say 10 to the power of 0, 10 to the power of 0 is 1. What does that mean? Let's say I say 2 times 10 to the power of 0, that would give me 2. 0.2 times 10 to the 0 is still 0.2. So 10 to the power of 0 is 1, like you're not moving your decimal at all. But if you say negative, like 10 to the power of any negative number, then you're moving your decimal towards the left. If it's 10 to the power of anything higher than 0, then you are moving your decimal towards the right. Okay, so 10 to the 2, you're moving it 2 spots towards the right. 10 to the negative 2, you're moving it 2 spots towards the left. Now, if you are asked to convert from the metric system to the English system, which is like inches, gallons, quarts, ounces, pounds, yards, you would get those conversions in front of you. So you're not really going to rely on that previous chart that I showed you, you're just going to rely on those conversions right here. So let's say, and you have also the conversions for the temperature, how to go from Fahrenheit to Celsius, etc. So let's just say that you want to convert, I want to convert like inches and centimeters. Okay, so let's take a look at an example right here. So let's say that I want to figure out 2 inches. What would that be in terms of centimeters? Okay, so again, if I want to show my work, so here's my 2 inches. Okay, I'm going to put my inches on the bottom so that it can cancel out. I'm going to put my centimeters right here. Now, because this is not the chart, the whole rule of the larger unit gets the 1 next to it, that doesn't apply here. So all you're going to do is take a look at the conversion that you have, and you're going to just going to see what they are, what they're telling you. So they're telling you that 1 inch. So 1 inch, so I'm just going to put the 1 right here. Okay, 1 inch is equal to how many centimeters? Well, 1 inch is equal to 2.54 centimeters. Okay, so again, look at that conversion that they've given you, and all you got to do is write down the numbers, and once you do, go ahead and notice how 2 is next to 2.54. So you're just going to multiply the 2. So 2 times 2.54 should give you something like 5.080. And don't forget your units, centimeters. Okay, or you could say 5.1. Okay, you can definitely round. Let's say that you want to, so again, whenever you want to go ounces and mils, quarts and liters, again, use those conversions right here. Let's see. Let's say that you want to try going centimeters to Fahrenheit or Fahrenheit to centimeters. So let's say I want to figure out 72 degrees Fahrenheit. Okay, what would that be in terms of degrees Celsius? Okay, so what you would do is let's go ahead, and we're going to go ahead and use this equation because I want to figure out my degrees of Celsius. So I would do, so here's my degrees of Celsius. I want to figure that out. So I'm going to do my 72, right, Fahrenheit, and then equation is telling you to go ahead and minus 32, and then you're going to multiply your answer by 5/9. What I would do first, okay, your calculator, I would do 72 minus 32 first, okay, and then after you get your answer, because sometimes if you punch all of the numbers right away on the calculator, sometimes it's not going to give you the correct answer. So whenever you have a whole bunch of steps that you need to do, you can punch it all your calculator, but make sure you're putting parentheses, otherwise it's going to give you the wrong answer. Or just do it one step at a time. So 72 minus 32, that's 40. And then I'm just going to go ahead and multiply that by, 5/9. So again, you could just do 5 divided by 9 first to kind of see what that gives you. Again, because if you don't punch it in correctly on your calculator, it could kind of, again, give you something really weird. So, and then you would just go ahead and multiply. So 5 divided by 9 is 0.556. Multiply that by your 72. So the answer is 22.24. Don't forget the units. Okay, so 22.24 degrees Fahrenheit. So that's, those are some conversions right here. If you ever want to convert between the metric system and between the English system, those are the equations that you would use.